talks, Vaagn Toukharian.
Good morning. Thanks, BruCON crew. Thanks for inviting. And thanks for this time slot. I guess organizational team realized I'll get drunk soon, so they pushed me to early slot. So let's hope this works. All right. So this talk was developed by my colleague Tigran Gevorkyan and me, and I was supposed to come with Tigran, but he didn't come. But I brought my beautiful wife with me, and that works out better because Tigran is a male, my wife is female, mostly for that. So who we are, both Tigran and I work for Qualys, and we do break stuff, and we also share a couple of other interests, as we like time travel, who doesn't, and we love to try. We love to swing, bike, and run, and looks like Rouge and Ghent is a beautiful place for that. But we'll talk more about breaking stuff and time traveling today, not so much about biking and running. So what we will talk about is a method and a tool that we developed, which is for stressing your web applications. Then we'll go through some statistics. We will go deep into the defense against the method or any other denial of service attacks, mostly layer 7 attacks. We'll talk about possible usages for the method. So why do we decide to spend time on doing some research and writing code and developing a talk about it? Because we wanted to buy a time machine. This is a time machine that we tried to buy. You could buy something like this on eBay, but I'm guessing it's not working. So what we developed is kind of a time machine that has only one function, and it does that function well. And a function of that machine is to give you information from the future about the state of your website. That was a joke. So why do we talk about denial of service attacks over and over again? It's supposed to be very dumb and simple thing, and everybody knows how to crash somebody else's machine. Why do you come up with new ways of figuring out what to crash, how to crash, and why all that? Because it's interesting, crashing stuff is fun, and then it's also good to know how to protect stuff, even though we can't protect from everything, but it pays off to be prepared. So here is a little bit of taxonomy by Anton Vaagn. This is a denial of service classification. So basically, sometimes we want to just crash stuff, and that's also working because basically the system will deny any access to it if it's dead. Then there are a bit more clever methods of resource consumption. Those are on different levels, network level, infrastructure level, or going all the way up to protocol level, and finally application layer, which we are interested in, and this talk is mostly about that. And there are some new business logic layer attacks too. So let's talk about application layer denial of services. So the good old way is just do lots of gets on index HTML of the web resource and see if it dies, and If you happen to have some money and Russian connections, you can do 10,000 or 10 million of those simultaneously. But this method is expensive and there's no feedback, you don't see what's going on. And resource consumption can be near symmetrical, which means your client, the attacker client and server may suffer similarly. And then are these smarter bots with new breed of DOS tools, slow start tools, slow read, slow HTTPS, slow read. Those guys are usually not doing brute force gets or posts. It's more like prolonging the connection, reserving stuff on the server that they don't use, and they just hamper that, and they won't let legitimate users to get to those resources, simply put. And then there will be cases of PKI abuse or cryptographical API calls or renegotiations that will be costly on the server. SQL wildcards, if are used in any of the fields or forms or any of the resources, if used, if unfiltered, go into web application logic and are part of the SQL statement, may cause SQL DBs to overheat and stuff like that. And then WebSockets have possibility of helping with all of that, because if someone sets up a WebSocket server and doesn't set it up right, or sets it up by default, a legitimate use would be that you go and connect to it and it keeps the connection alive, which is unlike the regular HTTP transactions. And that is basically like help coming from the server itself, and you are doing the slow HTTP read or write or low-risk attack without even striving to do that. The WebSockets infrastructure does it for you. It keeps the connection alive, and then the only thing attacker should do is just open up enough connections to kill the server. Okay, some exotic level 4 attacks, as we talked about a minute ago. Wildcards in a SQL queries could overheat your DB. And this year at DEF CON there was a talk about using genetic algorithms for smarter SQL injections. Imagine using the genetic algorithms to come up with harder and stronger wildcards. Basically, wildcards that you fit to the SQL query and it works harder and longer. That could be automated. Some business logic above level layer 4 attacks would be like if there are flaws in business logic, attacker could put too many items in a cart and overwhelm system, or if logging infrastructure is not optimal and doesn't withstand huge traffic, you could have your service degradation on that end and stuff like that. So what is the proposed method? This is not an exotic method. It's just a get flooding that we propose. I mean, we don't propose anything really. It's just we are rehashing it, and we are providing a tool that will get you a resource that is useful for get flooding, and it will also help you to get flood. So it's not exotic, it doesn't do anything fancy, like genetic algorithms are not involved. It's not one of the slow start attacks, it doesn't have the trickling down the data or keeping connections alive kind of problem. And it's not trying to kill your server by just allocating more than 20K of connections. As we will see later on, only 5 to 10 connections sometimes are good enough to take down a very powerful server. So resource consumption is asymmetrical by nature for any web transaction, because server really has to work more than a client, unless that client is a browser and it's rendering JavaScript or something terrible. But if you are just talking about the request response, that cycle is asymmetrical, and what we are trying to do to increase the divide here, amplify the asymmetrical nature of the HTTP protocol. So finally, what's our method is just a get flood with some analysis done before the actual attack takes place. So how do we propose to detect a critical resource? And by critical resource, we mean a resource that consumes lots of CPU or has DB intensive stuff. We would use a crawler to go through the whole website if we can. Our crawler that we have right now is not too smart and won't crawl everything, but it's a good beginning, and we also have a way of feeding in data from different crawlers. And then we would continuously request those resources that we found and get average speed on those. And by having average speed, we will make some assumptions that those resources that have worse speed are heavy on the server side. It's that simple. Nothing really smart about this. So we think that resource size is not significant because the speed for a standard resource that is not heavy on a server, is gonna be more or less constant. And size doesn't matter here, although it may matter in some other places. So what we have here, so this is some statistics gathered by running the tool and looking at a couple of commercial and non-commercial CMSs. You would get a distribution like that, where you have your good resources piled up in this bunch, and those are slightly, those are normal speed, they are fast, and probably they don't do anything bad with CPU or DB, but then there is this bunch that is really slow, and what we are trying to do is to find those in an automated way. So that was the kind of the gist of the method, but then it wouldn't be perfect if my mathematician friend wouldn't start applying some statistical methods to normalize the data. So basically, this is all the mumbo jumbo he wrote here that I don't understand, and he basically tries to find the mean. And the lower is the standard deviation per resource, is the higher the confidence is that prediction or that calculation is correct. And then what we do, we will throw away all the resources that have big variance, meaning they have high standard deviation, and we end up with confident a list of links that we are confident that will stress the server more than anything else. So here we have 4 quadrants. In these 4 quadrants, what we are interested more is this quadrant where the standard deviation is lower than higher quadrants and the speed is slower than the corner right to it. So whatever drops into this corner, this quadrant is considered to be heavy resource. So time for a demo. This is good. So here we run this crawl on a localhost with depth of 3, which means do not go deeper than 3 levels when you find new links. An account would be how many iterations it will test, and then it will drop an XML with data. And the data that it found here is standard deviation and the speed. The speed and then standard deviation for all the resources. What we have here? Yeah, and this is sorted. This is sorted, and we have the worst cases on a bottom. Yeah, it doesn't show well. Let me scroll it a bit. Is it stuck? Yeah, even with the recorded demo gods are punishing me. Just a second, sorry. We'll try this one. This is nice, but it's not full screen. Yeah, it works. Okay, so this is the output XML that contains the resources with their corresponding means and standard deviations. And this is some random stuff. It's not useful because standard deviations for this web application are very scattered. As you see, it will go from almost 0 to 300 something. But then we'll see some more examples of better results. Runs on we'll see runs on the real CM commercial on non-commercial CMSs. This is the scatter point that it generated from the real data from the XML. We have also an option to graph your website or whatever we could crawl from your website, just for fun. And so this showed you few iterations it was running of the same resources. Like you see, index.html was run once and then once runs again, and in the end it will do the statistical analysis on those and will give up the consolidated results. So here we are running on a specific installation of a CMS, and it comes up with a couple of resources that have high resource consumption, like sitemap, surprise, Vaagn. And what we can do over that later, we can simulate a stress test and see what happens to the server at the time of the test. So here on the top you have a top of the web server. On the right you have the top of the client, and in a low left corner we are running the attack. It's basically running the tool 5 times in a row. So what it will do with provided XML, it will go and request those heavy resources over and over and over, in this case 1,000 times. But it is running only 5 threads, 5 processes, and only 5 requests per. 5 requests are done simultaneously. And as you can see, this server, which had 4 cores and 8 gigs of RAM, running i7 CPU, is almost down. The idle is only 1%, where this Ubuntu box was only 9%, and most of it is just the UI that is running. So that's the tool. Tool is available on GitHub, and the link will be at the end of the presentation for interested parties. So that was just a simple tool written in a couple of days, and to just show that there is still things to be done with regular get flooding. It could be done smarter. Of course, attackers were always doing smart things, and they probably have tools like this, but it's also good to have tools like this in the house and see how it affects your web server performance. So what we were planning to do in the future probably is going to be this attack-like stage of testing, where we basically run a couple of threads simultaneously and see how the resource degrades, and then we go back to our calculations and we adjust to it. So this will allow us to understand if we really guessed well, if our time machine worked well, basically, and if we are pointing out to the resources that really do degrade the server performance. So let's talk about the defense against tools like this. If you have a tool like this, what would you do? Of course, protecting from DDoS is a big task, and it's not 1 hour talk worth thing, or even not 1 day worth of workshop that can do it. I mean, it's really hard. But what we can still do for get flooding, at least, there are a few things that could be done. Suggestions would be using load balancers, using our tool to figure out the memory or CPU hogs and fix the bugs that you have if they are due to bugs, or try to optimize your code. We will go through a couple of Apache configuration suggestions that will mitigate get flood attacks. Some Apache modules will be considered, and of course this all will fail if a smart attacker you're dealing with a smart attacker, because you cannot really outsmart a talent by a machine or a standard method, universal method of any kind. So load balancers, there are few solutions in the market. I won't go into details, but most of the commercial vendors of the commercial load balancers, they promise that they will fight against those protections, and mostly those are rate limiters which are not good, and some way there are some filters and source IP checks, and all of those are faulty to clever attacks. There are also commercial, cloud-based denial of service protection services. Again, doing almost the same things as the load balancers will do, because they are basically, in some cases, load balancers or valves. So resource rate limitations, connection limitation, originating IP filtering, and in some of them have bonuses, like they have defenses against slow loris types of attacks. And some of them, like Cloudflare, even have some web application security features in them. So what's bad about them? They are mostly costly. We talked to a couple of real-life users of those systems. They say that they won't be enabling them with full throttle because they are afraid that the service degradation, not service degradation, but user experience degradation will appear for their customers. And there was a very good talk in Black Hat this year about DDoS mitigation bypassing, which basically says if you understand how the mitigation works, these commercial protection services work, you can fool them. Basically, you are just having randomized data sent to them. If there is a filter, if you figure out what kind of filter there is, you can fool it. Or what are the thresholds that they are set to, you go right under the threshold. So one other way of fighting with these level 7 denial of services would be using our tool, as we said, to use it as a QA instrument. Run it on your infrastructure, run it on your web application infrastructure, figure out what you have. If there are places where you think manual intervention is required, like there are fields that could be potentially used as vectors for, let's say, SQL wildcard injection, do that too, and figure out what you have, what's heavy, what's not. Maybe use protection methods. In the ideal world, our tool would generate config file for something like mode security that would take care of that, but that's probably too realistic, too optimistic. So in a couple of minutes, we'll try to go through some tweaks that we try to do with Apache configuration to mitigate DOS. Layer 7 DDoS. So what was the baseline? Baseline was one client, basically a laptop, running temporal requests to most expensive resources that we identified using the tool. The laptop was using only 3% of CPU, and the server running i7 with 4 cores and 8 gigs of RAM was maxed out on the CPU. So could we just use Apache Config to fight with it? No, not really. We couldn't find any standard config measures, but there are some modules that we use. So first module that we tried is mod security. Basically has a way of setting per IP limit and will block the violators. CPU usage was cut right away after the system detected the violators, and so the setup wasn't too hard. And the cons of this method probably would be, as with any other limiter-based solutions, that we could limit users that have heavy usage coming from the same IP corporate networks of some kinds, or slow consumers. So another thing that we thought of was mod security, kind of extension to mod security extension that would sit on a server and do whatever the tool does, but on the server side. So it will identify the heavy resources and then figure out of ordinary flaws that lead to the resource and semi-intelligently block those out. So that would be probably a bit better than just limiter solution, but that's still a theory. There is another nice module that does basically the same. It's easier to use. You just set it up, max count per IP, a number, and it will never let anybody to get above that number. Very crude method, works fine if you are a small corporation. You just want to mitigate those right away in an hour or so, or 10 minutes. So basically cuts down the CPU usage to some number, some acceptable number. In our case, all the numbers that we see here are real for that setup in a lab that we had. ModQS, a bit better solution. So bottom line is almost the same as the limiter module that we had on the previous slide, but it also has a benefit of having another setting that will mitigate slow DORIS type attacks simultaneously. This module is very complicated to set up, but it's probably better solution because its limiter is not crude. It has this notion of credit, so it will let you go a bit deeper than the threshold, and then will start closing down your connections. Mod throttle, I found this module, but I couldn't use it, couldn't compile it, and I got angry, and hence this slide. Mod evasive, very good solution for majority of small businesses. We think this really works, easy to set up. That should be it for that. So with all these Apache models that we went through, what we think would be a problem if we also want to mitigate slow DORIS type attacks, no problem there. The mod evasive couldn't protect from those, but there was ModQS that could, or Apache Configs, config directives listed on the bottom could help with mitigation of slow attacks. So before jumping into commercial solutions, probably it's a good idea to give it a try and see how it works for your local setup. And I wanted to just point out this module, which sounds promising, but I don't know if it works yet. So basically what it does, it uses Project Honeypot to collect the violators, and it has the IPs of all the violators, and then you could use that to blacklist them. Sounds like a good idea. So how we can use this, whatever we just described, we could use it for good, use it as a QA tool, use it for stress testing, figuring out what goes on in a case of attack. We could use it for bad, with a slightly harder analyzer that we don't have yet, but everybody could probably do it, like running the same thing in a couple of threads and see what happens to a machine. And of course, in a very ugly way, and you don't want to do that. So back to the future, back to the ideas that we wanted to do, going into the future. We want to understand how the load balancers really work under those get flood attacks. We want to figure out if we can automate SQL wildcard injections, maybe using the genetic algorithms. See if state reset costs could be also automated, and like how dropping the cookie or invalidating the session and seeing what happens there. And of course that semi-automated attacker analyzer that we talked about. So with that, I'm done. Thank you very much. And here is the GitHub link to the tool. If you're interested, you can download and play with it. Thank you. And the references are all at the end. And it wouldn't be a good talk if there is no cute kitten in it. So this is one of those cute ones. Thanks. And if you have any questions, sorry.
Question about a more theoretical type of attack. I never saw it or heard done, but I was participating in the theoretical discussion. It's an economic DOS, and the basis is that some company having their website on the cloud, so on some provider, you just make enough traffic, and you just make it. You just make enough usage on the resources that the company doesn't get anything out of it because there is no customer generated, there is no sale to be done. But on the other hand, they have to pay a provider, the cloud provider, for the cycles of the CPU and the memory that was consumed. So the only thing you need to do is to figure out the way to increase the bill they are getting from the cloud provider. Did you have some kind of examples like that, or is it theoretically valid hypothesis?
Whatever you said makes lots of sense, and basically this could help with it. I mean, if you know that he is like whoever you're trying to offend runs Joomla, and you know what's the heaviest resource that Joomla has, because you did the analysis, and you're just hitting his resource, that particular Joomla resource, he's going to pay lots of bills. And you are not going to pay that much because it's really asymmetrical. But we didn't do any research towards the economical DOS that you brought up. No. Thanks for the idea, though.
Hi. How does your tool compares to other stress testing tools like JMeter or CERTs, where you can also look into different paths, like different use cases with authentication, etc. What does it make it different, and how does it compare to those?
Yeah, that's a very good question. And we didn't do analysis of comparison, but the main point of this tool is to just cleanly have time-based analysis, nothing else. It's just predicting from the time of transfer, nothing else is in the play. And the promise was to have, if you have a good body of sampling, you will statistically reduce valid numbers somehow. But we are planning to run it against some other tools and see how we do it.
Thank you.
Thank you.
No more questions? All right.
I want.
Hi. Can you elaborate on the part where you go from the calling to the timing? Do you do a timing of the page, or do you insert the parameters, and do you do fuzzing on the parameters?
A good question. So no fuzzing is done. So that would be, your second question was if we do fuzzing and see if timing changes with fuzzing. Yeah, that would be one of the future developments. Part of it was the SQL wildcard injection. We could also try some other things that we think are sources for internal resource consumption. It wasn't done, and so these are, as I remember, your first question was, do we time it? How do we time it? Yes? What time our clock starts?
Do you identify all the parameters, or do you measure the page?
I'm sorry, do we measure?
The load of the page, the time.
No, we don't. So this is not. The client side doesn't have any bearing here, so we don't care how long it does it take to render the page or anything. It's the transfer time that we are interested in. And time from our request being sent to the time of completeness of the response. Because we believe that request send time is constant if you have big data, big number of samples, large number of samples. So speed for response traveling back is the same, and only variance in the speed is the load on the server. So we measure the whole time from request being sent to the last byte in. Thank you.
As you do more and more requests, the server gets more loaded. So do the previous requests you do not influence the latter ones because you already generate more load? Because you try to check what is the most heavy page, but when you already did like 400 checks on that server, it already will have some load because you already generated that traffic. Will those previous ones not influence?
Yeah. So that's a really good question, but maybe it will happen in an opposite direction. Maybe you will see better numbers, not worse numbers. In some cases we see, but the load will be alleviated because you stop the previous request, you stop the previous series, and then you're starting with a new series of experiments. So they are kind of independent. They're supposed to be independent, unless your server type already or semi-dead, and then you're just kicking it in the head. That is also possible. That's why you have to have a large enough number of samples to figure out if you're degrading really because of
your room load or because of
yeah. And a good thing would be to have the power to see really if you are your server performance degrades because of the cumulative load or no.
Okay.
Thank you.
That would be.